Okay, we're going to look over your warm-up for Tuesday of this week. All right, so here, this looks a little bit different than maybe what we've been used to. So I'm going to walk you through how to do this. So you're just classifying each item by its solubility and magnetism. So you're just checking the properties that match, basically. So like aluminum is non-magnetic, so I'm going to check non-magnetic, and it is insoluble. Okay, so you're just placing a check mark under the properties that match that item. So nickel. So remember, there are only four metals that are magnetic: steel, iron, nickel, and cobalt. Okay, so all other metals, so aluminum, gold, are all those other metals that are not those four are going to be non-magnetic. So nickel would be non-magnetic, and it is insoluble. Remember that soluble means it can dissolve in water. Insoluble means it cannot dissolve. So cork would be non-magnetic. Oops, I did this one wrong. Should be magnetic. Yeah, sorry, I clicked wrong on that one. Nickel is magnetic. Cork is non-magnetic and it is insoluble. Foam would be non-magnetic and insoluble. Syrup would be non-magnetic, but it is soluble. Remember, all syrups are soluble. They're all sugar-based. Syrup is a sugar-based substance. And so because sugar is soluble, all syrups are soluble. So that would be, pancake syrup, maple syrup, corn syrup, chocolate syrup, all of those would all be soluble. Of course, sugar is non-magnetic and it is soluble because it will dissolve in water. Gold is non-magnetic and it is insoluble. Salt would be non-magnetic, but it is soluble because salt will dissolve. Steel, remember the four metals is steel, iron, nickel, and cobalt. So steel is magnetic, but it is insoluble. Sand is non-magnetic and insoluble. Okay. All right, how many bulbs will remain lit if wire 4 is removed? So if I cut off this wire here, if I cut here, and I use my pen to trace a path now that I've cut that wire. So remember, you start at the batteries and you're looking for a complete path. So any bulbs that are still part of a complete path will be able to light. So if I start here, now I can't go here anymore because I've cut that wire. So I'm going to go this way and I'm able to get through both of those bulbs and back to the batteries, which means that both of these would light up. So 2 light bulbs would light up, even if I remove wire 4. Okay, select the correct definition for each word. So I have light bends and light bounces back. So reflection would be light bouncing back. Refraction would be light bending. Which of the following describes one way to model the formation of a canyon? So remember, a canyon is formed by rushing water. So canyons are formed when rivers over millions of years cut through the earth or cut through rock, and they dig out those canyons. Remember, canyons usually have a river at the bottom because they were formed by that same river. So we are looking for a way that we could model the way that a canyon forms. So drag an ice cube through dry sand. That would be more like a glacier. So an ice cube forms, the ice cube would represent the glacier, and this would represent the formation of a U-shaped valley. Remember, U-shaped valleys are formed by glaciers. Blowing on dry sand with a straw. So we've got dry sand here and we are blowing on it. That makes me think we're creating wind. So that would be a great model for sand dunes, but not so much for a canyon. Placing several rocks inside a water bottle and shaking it. So this would be a great model of weathering because those rocks are going to hit up against each other and start to break each other down. So that would be a great model for weathering, but not so much for a canyon. Pouring water over damp sand that has been packed down. So this is going to be the best one because I've got water and I know that water does form canyons. And when I pour that water over the damp sand, it's going to cut through that sand and kind of model what a canyon looks like. So that's going to be my answer. Okay, the rock below is formed from sand and bits of shells. What kind of rock is it? So you can see the rock here. You can see that it's got lots and lots of bits of shells and other sediments. So it is a sedimentary rock. Remember, sedimentary rocks are the ones that are always going to contain fossils because of the way that they're formed, because sedimentary rocks are formed over millions of years from layers being packed down and deposited upon each other. And a lot of times organisms, like the ones that lived in these shells, get trapped in those layers. And so that's why we always find fossils in sedimentary rocks. All right, more check boxes. So there's going to be more than one answer here. So select the processes that are necessary for coal formation. So I'm only going to place a check next to the things that are needed for coal to form. So I do not need heat from the sun. I do not need photosynthesis. Remember, photosynthesis is when plants make their own food. So that doesn't really have anything to do with coal formation. Ancient plants die and get buried. Yes, that's the first step in the process of coal being formed. We do not need volcanic eruptions. Layers of sediment build up over time. Remember, those plants have to be buried by the layers of sediment, so that works. We are going to need that for coal formation. We do need millions of years to pass. Ancient ocean organisms die and become buried. So this would be more, because it's ocean, that would be more for oil and gas formation, but not coal. Remember, coal goes with plants, ocean goes with oil and natural gas. And then heat and pressure, of course, we need heat and pressure for coal formation. We also need heat and pressure for oil and natural gas too. All right, that's going to be it.